He'd been repairing eyeglasses for 17 years, adjusting frames, replacing lenses, helping people see clearly on modest budgets. Just another elderly craftsman trying to stay active in retirement. Until a laser safety incident at the nearby research facility threatened to blind dozens of workers, and suddenly the quiet optician revealed why he understood laser optics that stumped safety engineers. Edgar Raymond Holbrook was 79 years old, with silver hair that caught the light from his magnifying lamps and pale green eyes that could detect optical imperfections invisible to most people. His steady hands worked with microscopic precision despite his age, adjusting temple arms and aligning lenses with tolerances measured in fractions of millimeters, while his voice carried the patient cadence of someone who understood that vision was too precious to compromise with hasty work. Welcome to the Human Stories. Before we continue this incredible tale of hidden expertise and sight-saving knowledge, tell me in the comments what city you're watching from today. And if you believe stories about quiet masters deserve to be heard, hit that subscribe button. Holbrook's Optical Repair occupied a narrow storefront on Main Street in Cedar Ridge, Colorado, between a used bookstore and a cafe that had been serving the same community for 30 years. The shop was organized with scientific precision. Frames categorized by material and style, lenses arranged by prescription strength and coating type, and repair tools displayed with the methodical organization of someone who understood that efficiency in workspace supported excellence in craft. Edgar had operated the shop for 17 years, transforming it from a struggling eyewear retailer into the trusted optical service that Cedar Ridge residents relied upon for repairs that other shops couldn't handle. His consultations went beyond simple frame adjustments. Customers received careful education about lens physics, frame materials, and optical principles that helped them make informed decisions about eyewear that would serve their vision needs for years. Mrs. Carter, these progressive lenses are showing stress fractures along the optical center. That usually means the frame pressure is creating distortion that affects your vision clarity. Let me adjust the nose pads and temple tension to eliminate the stress points. These detailed consultations represented more than customer service. They were informal optical engineering sessions that helped community members understand how precision manufacturing and careful adjustment could transform inexpensive eyewear into optical instruments that rivaled expensive designer frames. The local medical community had come to respect Edgar's expertise, with several optometrists referring patients to him for frame modifications and lens work that exceeded standard optical shop capabilities. His knowledge of optical physics impressed eye care professionals who had learned to trust his recommendations about which frame materials and lens coatings would best serve patients with specific vision requirements. What none of them realized was that Dr. Edgar Raymond Holbrook had spent 42 years developing optical systems with precision that made eyeglass repair look simple by comparison. Edgar lived alone in a comfortable house 15 minutes from his shop, a well-maintained craftsman-style home that reflected the organized mindset of someone who had spent decades managing projects where optical precision could affect everything from scientific research to national security. The main living areas were furnished practically but tastefully, filled with books that suggested intellectual curiosity rather than academic pretension. But the basement workshop revealed technical capabilities that exceeded retail optical requirements. The walls displayed engineering diagrams and patents spanning 4 decades of optical research, laser systems that had advanced scientific instrumentation, precision optics that had improved manufacturing quality control, and safety equipment that had protected workers from optical hazards in industrial environments. Bookshelves held technical references that most optical engineers would find challenging. Laser physics texts detailing photon behavior and beam characteristics, precision optics manuals for designing systems with nanometer tolerances, and safety protocols for protecting human vision from electromagnetic radiation that could cause permanent blindness. Dr. Edgar Raymond Holbrook, one of America's leading experts in laser optics and industrial vision protection. His career had focused on developing optical systems for scientific research, manufacturing applications, and defense projects that required precision beyond anything civilian markets demanded.
But equally important, he'd established safety protocols that prevented optical accidents in workplaces where powerful lasers posed constant threats to human vision. The work had taken Edgar from laboratory research that pushed the boundaries of what was possible with coherent light to industrial applications where laser systems improved everything from automotive manufacturing to medical procedures. His expertise had been crucial in developing the safety standards that govern how American industries used laser technology without endangering workers who operated equipment capable of causing instant, permanent blindness. Retirement in 2007 was voluntary rather than mandatory. Edgar had accumulated enough years in optical engineering to retire with full pension while still young enough to pursue hands-on work that didn't involve the corporate pressures and classification restrictions that had characterized his professional career.
The optical repair shop wasn't about financial necessity. His defense industry pension provided comfortable retirement income. It was about continuing to work with optical precision while serving individual customers rather than military contractors, using technical knowledge to help people see clearly rather than developing weapons systems, and applying analytical skills to craft work that protected vision on a personal rather than industrial scale. But 42 years of optical engineering expertise doesn't disappear because someone changes from defense research to retail eyeglass service. And Edgar's trained eye continued monitoring optical safety issues that could affect his community and the broader region. Friday, August 23rd started like every other workday. Edgar arrived at his shop at 8:30 a.m., reviewed overnight orders for replacement lenses, and prepared for another day of providing optical services that helped customers maintain clear vision despite the challenges of aging eyes and limited budgets. The morning proceeded normally until 11:45 a.m., when Dr. Patricia Valdez from the Mountain Research Institute rushed into his shop with concerns that triggered 42 years of laser safety experience. "Edgar, we need your help. We've had a laser safety incident at the Institute, and 3 of our researchers are showing signs of retinal damage. The safety engineer says their protective equipment should have prevented any exposure, but something went wrong." Dr. Holbrook's optical engineering training activated pattern recognition developed through decades of investigating laser accidents. "Dr. Valdez, what wavelength laser were they working with, and what type of protective eyewear were they using?" "Near-infrared, 1064 nanometers Q-switched ND YAG system. They were wearing standard laser safety glasses rated for that wavelength, but the exposure occurred anyway." Edgar had encountered similar scenarios during his defense industry career, when laser safety equipment had failed due to manufacturing defects, improper selection, or fundamental misunderstanding of how protective optics interacted with specific laser characteristics. "Dr. Valdez, can you bring me the protective eyewear they were using? And I'll need the technical specifications for the laser system involved." Over the next 2 hours, Edgar conducted systematic analysis using techniques learned during 4 decades of optical safety investigation. Physical examination of the protective equipment using precision optical testing equipment he maintained for lens verification. Analysis of laser specifications to determine exact exposure characteristics, and correlation of safety equipment ratings with actual protection requirements. What he discovered was worse than routine equipment failure. The laser safety glasses had been manufactured with optical density ratings that met standard specifications but didn't account for the specific pulse characteristics of Q-switched lasers. The protective eyewear was adequate for continuous wave lasers but provided insufficient protection against the concentrated energy pulses that Q-switch systems produced. Dr. Holbrook was looking at a systematic failure in laser safety standards that affected protective equipment throughout the optical research industry. He needed to report his findings to appropriate authorities, but doing so would require explaining how an eyeglass repair shop owner possessed the expertise to conduct laser safety analysis that exceeded capabilities of most commercial testing laboratories.
Dr. Holbrook faced a choice that would define his impact on optical safety. He could file routine reports through commercial channels, hope that OSHA investigators would eventually identify similar safety deficiencies through their own testing, and risk allowing laser safety equipment failures to continue while bureaucratic processes slowly address threats that were actively endangering workers throughout the laser industry. Or he could use 42 years of expertise in optical engineering to protect vision safety the way he'd been trained to do when similar threats emerged during his corporate career. Dr. Holbrook made his decision in approximately 30 seconds. He contacted OSHA's Directorate of Technical Support through professional networks that retained his security clearances, identified himself by credentials that carried immediate authority among optical safety officials, and provided detailed analysis of safety equipment deficiencies that indicated systematic failures in laser protection standards. OSHA Technical Support, this is Dr. Edgar Holbrook, retired optical engineer. I'm documenting laser safety equipment failures that indicate systematic inadequacies in protective eyewear standards for Q-switched laser systems. Dr. Holbrook, this is safety engineer Michelle Rodriguez. Can you provide specific technical details about the equipment failures you've identified? Edgar's voice carried the clinical precision that had characterized thousands of similar safety consultations during his corporate career. Engineer Rodriguez, I'm analyzing protective eyewear with optical density ratings that meet current standards but provide insufficient protection against Q-switched pulse characteristics. The safety glasses are rated for average power but don't account for peak power densities that can cause retinal damage. Sir, our laser safety standards are based on extensive testing and industry consensus. Are you suggesting that approved protective equipment is inadequately protecting workers? Engineer Rodriguez, I'm providing analysis based on 42 years of laser safety research and accident investigation. The current standards don't adequately address the unique hazards of pulsed laser systems that are becoming increasingly common in research and industrial applications. Within 48 hours, OSHA laser safety specialists were conducting emergency assessment that confirmed Edgar's analysis. The laser safety equipment standards had indeed failed to account for technological developments in pulsed laser systems, creating protection gaps that exposed workers to vision-threatening hazards. Dr. Holbrook, how did you identify the safety standard deficiencies so quickly when our established testing procedures didn't detect these problems? Engineer Rodriguez asked during the safety investigation coordination. Edgar looked around his optical repair shop that had been transformed into a federal safety investigation center. Engineer Rodriguez, I've spent 42 years designing laser systems and the safety equipment required to use them safely. The protection gaps became obvious once you understood how Q-switched pulse characteristics interact with optical density ratings. The safety standard revisions that Edgar's analysis had initiated were implemented within 6 months, establishing laser protection requirements that eliminated the vision hazards he'd identified, while creating safer working conditions for thousands of researchers and industrial workers who used advanced laser systems. The story remained largely within optical industry publications, protecting both operational credibility and Edgar's privacy, while ensuring that laser safety protocols incorporated lessons learned from field analysis techniques that could complement standard safety testing. Edgar returned to his optical repair operations, serving customers with the same careful precision that had characterized his pre-emergency work. But something had changed in his approach to optical safety and his understanding of how his expertise could continue protecting vision health. Edgar, thank you for identifying the problems with our safety equipment, said Dr. Valdez when the Institute resumed laser operations with improved protective eyewear. Edgar looked up from the precision lens grinding equipment he was adjusting, his pale green eyes holding the analytical intensity that had never quite disappeared. Dr. Valdez, protecting vision has been my life's work. Whether I'm designing laser safety systems or adjusting eyeglass frames, the mission stays the same, making sure people can see safely. Were you really a laser engineer? Edgar smiled, adjusting his optical repair magnifier that covered federal credentials he'd hoped never to need again. I've spent my career making sure optical systems work safely for the people who use them. Now I get to apply that knowledge directly to helping individual customers, rather than designing industrial equipment. Dr. Holbrook continued operating his optical repair shop until he was 86, serving as informal optical safety consultant for OSHA while maintaining the trusted service that kept Cedar Ridge residents seeing clearly and safely. Because he'd learned that the most effective vision protection often comes from people whose expertise exceeds their visible roles, whose dedication continues regardless of official titles, and whose optical knowledge serves both individual customers and industrial safety with equal commitment to ensuring that people can see clearly without endangering their sight.